Hi everyone. Today I'm going to explain how to run regression and the results of regression using R. And primarily I'm using this particular data set, King County house price data set, for predicting house prices. In order to predict the house prices, I'm going to use the features and some of the available information which is there in the data is nothing but ID, that is nothing but a unique identifier, which is not required for running regression. I have date, price, bedrooms, bathrooms, square feet living. These are all, I believe, it's logically understandable, and therefore I don't need to explain it. The explanation is also given here, and followed by that number of floors, whether this house got a water frontage or not. It's mostly a categorical or a dummy variable. View, it's a continuous variable. How many view has been received? And condition of the house, it's a continuous variable. Higher the value, better the condition of the house. We have the grade, square feet above, square feet basement, and year built. And year built is nothing but in terms of year. And year renovated, whether the house is renovated or not, mostly. And zip code, latitude, longitude. This square feet living is the latest square feet living, and square feet lot is also given here. If you see, there are some other variable which is repeated here, right? Is it? But this is the latest one. And so this is actually the information here. In this case, I'm going to use price as the dependent variable, all the others as independent variable, but I need to clean the data before getting into that. All the others, in the sense, I want to select some selected variables. Let's see what could be the selected variables. Let us proceed with R. Before proceeding with R, let me show you the data sheet. This is what the data sheet which I'm going to use. This ID, date, and all the columns. The price is going to be my dependent variable. All these I may apply as independent except some variables. Okay, let us proceed further and understand how do we run regression analysis using R. So in this case, I have already set up the working directory. So my working directory is active. Therefore, I just need to read the data. And my data name is KC underscore house underscore data. It's an Excel file. Let me read the data. And before reading the data, let me activate the library. In order to read the same, I need the library read Excel. I have the library in my system, therefore I need to call the library function. Let me look at library read Excel. This is what the library, I'll just note it actually. Read the library for reading Excel data. So then second, read the data file. So I just use name is a data read dot underscore Excel. This library, whether it's not activated, let me activate the library. I use the function read underscore Excel. This function I just apply, and then my data name is KC underscore house underscore data. Let me see whether path does not exist. So let me look at the library here. KC underscore house underscore data. The data name is correct. And let's see. Here I need to keep that extension also. It could be the extension problem. Still, there is a problem here. It means that I need to check the files here. So my path is not activated. Let me activate the working directory. I'll go to session, working directory, choose the directory. Let me choose a directory. I have so then I have regression analysis. Let me look at, yes, it's a CSV file. Okay, it's a CSV file. Then in this case, I don't need a read Excel. I can say read.csv. So I already done that read Excel, but it's not required. It's not an Excel file, it's a CSV file, read.csv. KC house underscore data.csv. It's fine, it's read. Let's see. Now I have this data here. Let us actually start cleaning. Let's assume that here we have a date column. Date column it is not in date format. Let us start one after other. Here I can say check the date column and convert it as date. Let's do that. And str data dollar date, if you see, so it's a character, is it? So let me convert as data dollar date, and I just say as dot date function. So my data dollar date. So I just say the format is right now. It's nothing but percentage year, capital letter. There are 4 digits. There's no space. Again, I'll mention percentage month, percentage T, say T. 6 zeros are there. This is what the current format, and after that, if I check the structure, it becomes date format. Once you get the date format and generate the age of the house, so not to generate age of the house, I just want to look at 2 columns here. The first column is year built, and but year built is only year, so it is nothing but, this is nothing but the date of sales. Okay, so you can understand year data sales minus year built is equal to what, age of the house. So but the point is that these two are in different format. I need to pick up only this a particular element out of the date, and I just want to calculate age out of that. So in this case, what I do, I just use the function package lubricate, and I just get data, create a new column age. So I'll use the function year from lubricate. You can see that's year. I want to pick up year of what, data dollar date, and I just minus data dollar year built is going to be your age. If you see, you can see here, so age has been calculated. So that way age has been calculated. So in this case, we need to check the other columns, water frontage, or let us look at, for example, here we have year renovated. Now we have year renovated got a problem here. So have you seen the problem here? Year renovated consists of zeros and years, and we need to make it in common format. So I just thought of making wherever zero is there, keep it as zero. Otherwise, wherever there is an year, I'll make it as one. I'll convert it as a dummy. Let us convert as a dummy using convert year renovated as dummy column. So let me do one thing, date of dollar year renovated. I'll just call it as if else function, and data dollar year renovated, and is equal to 0. Keep it as 0, and otherwise I put it as 1. That is nothing but renovated house. That's what I meant. I just also make it as a factor, and so that I just need to add. So then I need to check whether there is a problem here or not. Call it as exactly double equal to 0. Yeah, done. Okay, so let's see, here renovated. Yeah, it becomes zeros and 1. It becomes a factor. Now I have any other columns which requires transformation. Let's see. And I'll also make water frontage as also a factor vector. And let me convert water frontage as also a factor vector. So data dollar waterfront, I just make it as factor data dollar waterfront. All right, then I need to check the missing data. I can do two ways of mixing data. I can print the summary of my data, or I can look at some of is.na of my data. Both the ways, summary will print the summary and it will print how many are there. Let me see how many missing data is there or not. So here you can see the missing data as such. You can see, let us look at whether there is some missing or not. Here there are two NAs in square feet above, but otherwise there is no missing nowhere. So let us proceed in terms of handling this missing data. I'm just going to apply so I will drop the missing data, get a clean data. So what I do, I'll create the missing data. Let me look at data only. I'll say na dot omit of my data. So let me get, right now I have 21,613 observation. Let's see after that what is going to happen. It become 21,611 and two observations got dropped. So now my data is ready, and let me look at the data here. Now let me do one thing here. In this case, let me delete some unnecessary columns. Column number 1, 2 is not required, and square field living and square field lot also not required because it's redundant, and because here there is square field living and later square field living and plot is there. I don't need zip code, latitude, longitude, and year built as well. All the other columns I need for the time being, and let us actually drop the unnecessary columns. So I'll type and say that drop unnecessary column from the data. I'll just say that data cleaned is equal to its function of data. I want to keep all rows. I want to clean 1 to 2. Let me see, column 1 and 2 I want to drop it. Column number then 6, 7 I want to drop it, and I'll type 6 to 7. Then let me look at what are the other columns, and yes, column number 15 I want to drop. Then I want to drop 17, 18, 19. It means that 15, 17 to 19. Any other column? Let's check. So 17, 18, 19, 15, right? And I can see 6, 7, right? And 1, 2. 1 and 2. Yeah, 1, 2, 6, 7, 15, 17 to 19. Let me get the data here. I just got the clean data. So now data clean. So I just make it a section here. So I have the clean data here. All right. So this is what my clean data. So let me split the data as part of prediction. I need to split the data into train and test. So let me create one index which talk about sample of and raw of your data dot dollar cleaned, data underscore cleaned, and then I just want to see 80% of row data underscore clean. I'll create an index. It consists of 80% of index one. I just create something called as training, and training is nothing but I can say data underscore clean. May I just want to get all the rows of index with all columns, and I'll get the test. Look at its data underscore cleaned, where I just want to drop the index one and all columns. So if you see my test and training here, you can see my test and training. So my test data and train data, if you see randomly split, you can see 17,288 observations training and 4,323 in test. So in this case, let us run the model using train data, and so I just use run a regression model here, run a regression with price as dv. So let me make a model. I'll use a function lm. Price would be dependent on all the others as independent. Data is equal to training. That's it. And I'll make the summary of the model. And before printing, in order to get non-scientific perspective, I just get options. Says skyfen is equal to 10, so that I'll be able to get things in a non-scientific manner. Yeah, here you can see, and age positively influence, square feet lot negatively influence, and here you can see bathrooms positively, bedrooms negatively, and majority of the coefficients are statistically significant. So that's what the interpretation here. So, and water frontage, is it one is a dummy, because those houses with water frontage got higher prices, approximately this much higher prices compared to houses with no water frontage. Similarly, houses with the renovated or they are renovated got higher prices, almost $23,373 higher compared to the other houses which is not renovated. It could be the interpretation. So it's usual interpretation, and we need to check further. We need to check some of the assumptions. Let us check the assumptions, like let me check the assumptions, or I check the presence of outlier in the data. And how do we check? In order to check the outlier, I use IQR based approach. So first of all, in order to, I'll calculate Q1. Before that, I'll just get Q1 of, I'll use a function quantile, and of model dollar. And let me do one thing before that. I'll just get my data, that training. I'll add the residual there. It is equal to model dollar residuals. If you get the training data, if you see, the residual has been added at the end of it, and I can check the presence of outliers in the residuals. So let me look at quantile and model dot, not model dot residual, then training dollar residual. And then I can say P is equal to 0.25 is quantile 1, and similarly I'll get quantile 3 Q3, I'll make it 75. I'll also create IQR, then IQR function of training dollar residual. So I can run all the three. I'll get object training. There is a spelling mistake somewhere. So here it will be. Let me check. The spelling is okay. Let me check. Yeah, spelling mistake again here. Let me look at the spelling mistake. I'll replace it here. Fine. So then let me look at the equation. So what I do, I'll create max value is equal to Q1 plus 1. I'll say 1.5 times of IQR is max. Min would be minimum threshold. I just defined. This will be min threshold. Okay, min threshold will be Q1 minus. I'll make it Q1 minus 1 point. Then it will make it max would be Q1 plus 1.5 times IQR. So min and max I'll just identify. So what I'm going to do right now, I just trying to clean the data, and let me look at data no outlier is equal to before that what I do, I just have the library dplyr because I just want to filter. I'll use a function. My data is training, so I'll put percentage greater than percentage. I use a function filter. I want to residual. I want to filter residual, and I just want to say the residual greater than or equal to min and residual less than or equal to max. It could be data with no outlier. So if you want to see the data, we have out of 17,000 data points. You can see training. I just extracted data with no outlier. So this is going to be my new data, and also I percentage greater than percentage. But use the function select, and then I'll put minus residual because I want from the training data. I just want to drop the last after filtering. I just want to drop it so that in my no outlier data I don't want to see the residual column. Let me try in terms of cleaning it. Yeah, see that, see whether residual is, it's not there now. That is one. So I got the data right now with no outlier. So let us run a regression using data no outlier. Okay, so I'll say model 1. It could be, then I use lm here, price tilde all data is equal to data no outlier this time. So let's try, and I'll print summary model 1. So if you see your summary model versus model 1, so model we got 65% R square. Model 1 we got, let's see whether it's improved or not, 75% R square. Listen very carefully. One thing I missed actually while splitting the data, which is nothing but I forgot to fix the seed. Okay, so if you are not fixing the seed, what happens? So replicability is not possible. In order to replicate the data, I'll fix the seed. I'll repeat the process here, and so that you can all replicate the we all get the same set of data, and then let me look at everything here, and no outlier. Yeah, so this is replicable. Probably if you run or I run, and I'll get the same result. That's the reason. Okay, so let me check the presence of multi-collinearity. So let's look at, I need a package car library car. So here in this case, I just use the function diff. I'll say model 1. Let's check. So if you see, and generally rule of thumb says that if f is greater than 5, there is a presence of multicollinearity. Here there is no potential problem of multicollinearity, and I believe there is no problem as such, and we can proceed with predicting the test data and checking the accuracy. So let me do one thing. So I just create something that is predicted. I use the function predict. There I use my base model 1. It's actually cleaned model, and my new data I want to predict is test data. Let's see whether I am able to predict. So I got the predicted here. So I need to calculate prediction accuracy. So I need a package called as metrics. Let me get the package. So in this package, I need two things, and let me look at first of all MAP, mean absolute percentage error. I use the function MAP. I just use the actual data here, and let me look at test data price versus predicted. So MAP is here 25. I'll say accuracy is nothing but 1 minus MAP. So I can get it here. So 74% approximately accuracy. I can also look at RMSE. So let me look at RMSE. I use the function RMSE, and then exactly I'll copy paste here, and I'll use it. And if I want to get this RMSE, I can check it here. So this is what the RMSE which I generated out of it. So we got the MAP and RMSE. So we can use these or either of these values and build other models or algorithms. For example decision tree or a random forest or SVM or any other regression problems. We can actually compare. We can see that which one gives us the lowest RMSE or MAP, then we can say that that is going to be the best algorithm. So this is all about using regression for predicting the house prices. Thank you so much.